This is part 4 of the 7-part series in the example for sequence in software design. This part deals with the pseudocode, the actual how to do the problem, whereas output list and input list above were what do we need, what is going to be output, and what do we need for input list, but this is going to be the how of the problem. Right now we're going to deal with the pseudocode. So the first thing to do in pseudocode is to come up with a module name. All of our code this term, whether it be in pseudocode or in VBA, will be in a module. And the module needs to have a name. And that name should be made up to stand for what the module's doing, just like the variable name was made up to stand for the data that it represented. So in this case, we could come up with perhaps a lot of names, and it may be the case that you want to make a list and then pick the best one. The reason we want to spend extra time on coming up with good variable names and module names is that these names are going to also be in the physical code, and the better names that you choose, the easier time another person will have in reading your code, or even yourself 6 months later when you come back to modify the code. You may not remember everything you did, but if you made good module names and variable names, you should find your way around more easily. So in this case, we might come up with product, we might come up with multiply module, multiply as the name of the module, and there might be some others. This is not a specific application, so it's harder to come up with good names for the module name because it's a generic application. And the two names we did come up with, product and multiply, are fairly generic. Product is not a good one because there is already a variable name called product. So we're going to go with multiply. Okay, so we have a name for the module, and now we can put in the code. Now, if you're having some trouble figuring out what should be in the logic solution for code, you can sit down and solve a problem using some example data by hand, and every step you take by hand will be a step in the pseudocode. Pseudocode should be an explanation logically of how to solve the problem, but it should not be the case that it only applies to computer languages. So doing it by hand is a good way to decipher the logic steps that you have to go through. And if you're going to multiply two numbers together, the first thing you need to know are what are those two numbers. And that means that you're going to have an input step that has to be done first. Okay, so our verb, if you will, for our class standard for pseudocode will be the word input. You could use other words like fetch or get or whatever, but we need some standard, and we're going to use input. The next thing, after you get the two numbers that you know that you need to multiply together, you would multiply them together and get the product. So that's our next step. This is an assignment statement, and you can read about that in the text. We're taking what's on the right-hand side, in this case the equation num1 times num2, the result of that, and we're going to put it into what's on the left side of the equal sign. In fact, from other design methodologies, quite often an arrow is used to indicate the direction of the data flow here. But in pseudocode we have an equal sign, so we just have to remember that. We would not want to say, for instance, num1 times num2 is equal to product, because in an assignment statement the flow of the data is from right to left only. Okay, now that we have the product, what we want to do next is come out and tell someone about it, so that's an output statement. Notice that the verb we're using for outputting data is the word output, not display, not write. Write and display have problems in that they imply physical devices, either the printer or the screen, or print would especially be bad for us because we're trying to keep the physical devices out of the logic solution. So we'll stick with output this term. We want our logic solution to be simply output and not try to get into the physical realm of things. Okay, then the next thing we're to do is to end the module. We're done. The end module statement will be the same thing as the end sub statement in VBA, but it's not critical that you remember that, especially since the end sub is being supplied to you this term. You won't have to key it in. Notice the indentation of the module. Everything inside the module has been indented. The reason for this is to show dependency of execution. The statements in the module are dependent for their execution on the module being executed. This whole term will see other places where we will be indenting, and every time that we do indent, it will be for dependency of execution. This indentation that we're using here is the same indentation also that we'll be using in VBA, so there will not be a difference between the two. And this concludes part 4 of this 7-part series on the multiplication of two numbers sequence problem.